Today we are going to go over what's called an arithmetic sequence. Arithmetic sequence. Arithmetic sequence is a very common kind of sequence. And remember, by sequence we mean a list of numbers that is followed by a rule. So for example, this sequence of numbers here, we're adding one to the previous term, or actually let's use the algorithm. So that would be n minus 1. A sub n is n minus 1. And we can also have a sequence like this one. 2, 4, 6, etc. This is, algorithm of 2 times n. We could also have a sequence like this: 0, 1, 4, 9, 16, etc. If you didn't notice, this would be the sequence of squared numbers. So we are squaring each n. When n is 0, it's 0 squared, n is 1, 1 squared, 2 squared, 3 squared, etc. Okay, so by arithmetic sequence, we mean that the next term is generated, or the next term and the previous term has a common difference. So for example, let's look at our sequence, the first sequence here. The difference here from 0 to 1, the difference is 1. Here the difference is 1. Here the difference is 1. Here the difference is 1. So they all have the same difference. So this is an arithmetic sequence. How about here? The difference is 2. Difference is 2. The difference is 2. So again, they all have the same difference. So this is an arithmetic sequence. How about here? The difference here is 1. Difference here is 3. Difference here is 5. Difference here is 7. So the differences are not the same. So this is not an arithmetic sequence. So by arithmetic sequence, we mean a sequence where they have the same difference. And this difference, in fact, this difference is called the common difference. Common difference. So once you know the common difference of a group of arithmetic sequence, you can deduce the next term. So for example, let's say I have a sequence 7, 4, 1, -2, -5. And first of all, let's see if this is an arithmetic sequence. So the difference here is 3. More specifically, we subtracted 3 here. Again, we subtracted 3 here. And again, we subtracted 3 here. And again, we subtracted 3 here. So the difference is the same, meaning that it is an arithmetic sequence. Using this difference, can we deduce what the next term would be? Well, the common difference here is -3, because we're subtracting 3 each time. Notice that the sign is important for common difference. So saying the common difference is 3 is different from saying that the common difference is -3. So the common difference here is also going to be -3, which means our next term is going to be -8. So if we know the common difference of an arithmetic sequence, we can deduce our next term of the sequence. Okay, now a question that comes up with arithmetic sequence is, can we find the nth term of an arithmetic sequence? So remember, that was a little bit harder to do with recursive functions. Let's see what we can do with arithmetic sequence. So let's say we have an arithmetic sequence. It starts with a sub 1, and then a sub 2, and then a sub 3, and then a sub 4. And because it's an arithmetic sequence, it's going to have a common difference. So let's say that our common difference is D. So I'm using letters here instead of numbers to generalize this. So using this chart here, our first term is going to be a sub 1. And our second term is going to be a sub 1 plus D, because this D is the common difference. And remember, this is going to be a sub 2. A sub 3 is going to be a sub 2 plus D. We're just adding D to a sub 2 here to get a sub 3. And notice that a sub 2 is what we've defined here, a sub 1 plus D. So in fact, a sub 3 is a sub 1 plus D, or a sub 1 plus 2D. Okay, let me circle the terms here. Our fourth term would be a sub 3 plus D. Remember, we did a sub 3 plus D to get a sub 4. To get a sub 3, this was our formula for a sub 3. We did a sub 1 plus 2D. So this is going to be a sub 1 plus 2D plus D, which is a sub 1 plus 3D. And you can kind of see this visually here as well. To get to, this is our a sub 4. Now this looks a bit confusing, but if you look at a sub 1 here, and then a sub 4 here, to get to a sub 4 from a sub 1, we've added D 1, 2, 3 times, right? We've added D 3 times to get to a sub 4 here. So that is kind of represented algebraically here. We do a sub 1 plus 3D to get a sub 4. So now this kind of seems like we can find an algorithm from this. Notice that our first term was a sub 1. Our second term, a sub 2, a sub 3, and a sub 4. Okay, our a sub 1 was just a sub 1. A sub 2 was right here, a sub 1 plus D. A sub 3 was right here, a sub 1 plus 2D. And a sub 4 was right here, a sub 1 plus 3D. And you can also kind of see this graphically. So to get a sub 2, we just did a sub 1 plus D. To get a sub 3, we did a sub 1 plus D and then another D. So times plus 2D. And then like I showed before, to get a sub 4, I went from a sub 1 and added D 3 times. So notice the number of times we're adding D to a sub 1. So here we've added D once. Here we've added D twice. Here we've added D 3 times. The number of adding D to a sub 1 is 1 less than the terms. Okay, so this leads to the algorithm to get, if we want the a sub n term, that is going to equal a sub 1, and then you're adding D. How many times are we adding D? You're adding D n minus 1 times. Remember, when our n was 2, we've added D 1 time. When n was 2, we've added D 1 time. When n was 3, we've added D 2 times. When n was 4, we've added D 3 times. So we're adding D n minus 1 times. The reason for that is also graphically showing here. If we have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, the number of times we're adding the D is actually represented by the intervals. So to get to a sub 5 from a sub 1, we've had to add the 1, 2, 3, 4 times. It's 1 less than this number because there's 1 less interval than the number of terms. So if none of that makes sense, just remember this formula here. I would always prefer for you to understand the concept than just straight away memorize the formula. But I think if it's hard to understand the concept here, at least know the formula so that you can calculate problems involving arithmetic sequences. So this is the formula you can use to get the nth term of an arithmetic sequence. So if you have a question like this, let me give you a question. If the first term is 7 and the common difference is 11, what is the 10th term? Okay, so notice that two things need to be given here. We need to know that the first term is 7, and we need to know that the common difference is 11. Once we know those two, we can find the 10th term. So the 10th term would be a sub 10, right? And using this formula right here, this is the first term. So a sub 1 would be 7 plus n is 10, right? We're trying to find the 10th term. So that's n minus 1, which is 9, times d is the common difference. So in this case, it's 11. And now that is going to equal 7 plus 99, which equals 106. Okay, so the nth term, or the 10th term of this arithmetic sequence would be 106.